Hi, Year 11. This is the 2019 NCEA paper for 1.5 acids and bases. Okay, so we're going to go through this bit by bit, and there will be videos for all of it. So this is question 1. 2 boiling tubes containing both containing 10 ml of nitric acid, which is they've given it to you, HNO3. Boiling tube A contains 0.1 mole per liter of nitric acid, and boiling tube B contains a more concentrated 1 mole per liter solution of nitric acid. So a piece of marble chip, which they said is calcium carbonate, and they've given you the equation for that too, with a mass of 0.5 grams is added to each of the boiling tubes, and the reaction is observed and photographed. So here we've got a picture with both of them. It looks like there's bubbling that's occurring. One of them has a more concentrated, so this boiling tube B is more concentrated, and you can see more bubbles, and boiling tube A is less concentrated, and yep, obviously less bubbles. Okay, so the first question says write a word equation and a balanced symbol equation for the reaction between nitric acid and calcium carbonate. Okay, so first of all, the reactants here are nitric acid and calcium carbonate. Now, this is a neutralization reaction, which pretty much all the reactions that we talk about in this course are neutralization reactions. And it is turning to, so neutralization reactions always turn to a water plus a salt. So the salt is the beginning of one of these and the end of the other. So the salt is going to be calcium nitrate. And then also, because we can see bubbling there, and because we're dealing with a carbonate, we know that we're also going to be getting plus carbon dioxide. So the gas is being produced. Okay, so nitric acid plus calcium carbonate goes to calcium nitrate plus water plus carbon dioxide. All right, so now that is just worth an achieved, but the next part of the question says to write the balanced system symbol equation, and this can get you up to an excellence. So make sure that you can do that. So they've actually told you already what the nitric acid equation is, HNO3, and the calcium carbonate, CaCO, that's up there, CaCO3. And that goes to, well, we know what carbon dioxide is and we know what water is. The only thing that we need to figure out is what the calcium nitrate is. So we can have a look at our table of ions. We've got calcium here and nitrate here. So you can see that calcium has 2 electrons to give away and nitrate only needs 1. So that means that we're going to need 2 of these, okay, to balance it properly. So we're going to get CaNO3 brackets and then 2 of those. Okay, so the last thing to do is just to check if it is actually balanced. So let's have a look at this. So we pretty much just tick off everything that we've got here. So we have 1 hydrogen on this side, we have 2 on that side. So that's not good enough. We need to add this, bring this up to 2. Okay, so now we've got 2 hydrogen, 2 hydrogen. Then we look at the nitrogen. We've got 2 nitrogen on this side, so that gets transferred to that. And 2 nitrogen, that gets transferred to that in there, so that's good. Oxygen, we got 1, 2, 3, 4, 5, 6, which is good. And here we've got 1, 2, 3, and then in here we've got, over here, let's just go back a second. So in here we've actually got 6 of them because that's multiplied by 2, so 6, and then we've got another 3, so that's 9 in total. And over here we've got 2 plus 1, that's 3, and then another 6 in here. So that's plus 6, so that's 9 in total there. So we've got enough oxygen. Calcium, 1 here, 1 here, that's fine. And carbon, 1 here and 1 here. So it's fully balanced. So to get the achieved off that, pretty much just that. To get a merit, this but not balanced. And to get the excellence, everything that I've written there.